This is Raju. I'm going to present today the artist identification using CNN case study as my final project, and I will be moving back and forth from the PPT and the code to cover both the things today. So let's start with the problem statement. Artist identification is a task to identify artist of a painting given no other information about it. This is really a challenging problem for computer to solve because it does not just require to identify the object or the face detection, but artists can paint wide variety of objects and scene. So and also some of the artists over the period of time they change their style, and that's why this case study becomes really hard. I'll be using the WikiArt database, which consists of 150,000 paintings or 2,500 artists. The data set can be downloaded from Kaggle. I'll be presenting you various CNN models. Some of like one of them I developed from the scratch, and some of them are already implemented pre-trained using transfer learning. So just for the fun, I'm plotting here 100 paintings of Picasso. So this just to see what we will be classifying. Uh, about the software and the packages, I'm going to use Anaconda with Python 3.6. The Python package are pretty standard, which we have been using in our codes. Keras, NumPy, Pandas, Pillows for image processing, and some of the Keras pre-trained model like ResNet 50 and Inception ResNet v2. About the hardware environment, since I'll be running really deeper CNN networks, even though my computer is pretty good with 16 GB RAM, it was not sufficient. It used to take like 5 minutes just to finish one epoch, even with the small configuration. So most of the time I used AWS instance, which is P3.2x large GPU server. About the dataset, as I mentioned, I would be using WikiArt dataset downloaded from Kaggle. This is pretty huge database. As you see, there is 150,000 paintings, but I'm not going to use all of them. So when you go to this link and download the train.zip and test.zip, it's over 50 GB of data. Which is unbalanced data, so we are not going to use it. There is one CSV which mentions or provides more information about data. For example, what are the artists, what the file name is, and what is the size, and etc. For the data preparation for this case study, as I mentioned, it has huge data set and it's unbalanced data set. There are so many artists who has lesser than 50 paintings, and we, to get a better result, we don't want to provide unbalanced data set or insufficient data set for CNNs to give us some accuracy. So what I decided to use is find out the artists who has more than or equal to 400 paintings and get 400 paintings per artist of those artists. So total becomes 14,800. And then I divided that data into 80 10 10 for training, validation, and test set. Also, since it comes with the different shape and size, these are paintings, we have to unify the shape before providing to CNN. But instead of rescaling it, what I did is I decided to crop the image from topmost 224 by 224. And the thinking behind, instead of rescaling, why should we do the cropping? Because the rescaling will delete some of the features which could be avoided. So, and the methodology behind this is the style of artist should exist in any part of the painting and not necessarily the whole painting, and that's the reason I'm going to crop, and then I rescale the pixel from 0 to 255 pixel to 0 to 1, just for the faster calculation and better accuracy. So before going to the CNN process and different models, I would like to show the code of what we just discussed in next couple of minutes. So this is the information file which we download from the Kaggle, which provide what are the artists, what is their file name, and what the file size and etc. But mostly we are interested in artist who has more than 400 paintings. So this is how we group by to that list and find out who all artists has more than 400, and we got a unique list of artists are 37 of them which has 400 images. Then we are going to create the smaller data set with this kind of folder structure, so that we can use the image data generator from Keras to feed in the data to our various CNN models. So this is the code where I create the smaller data set, which nothing but take the all the data from the artist, which we identified those 37 artists, and take 400 images each, and just divide those into 80 10 10 percentage for validation, training, validation and testing. And before doing or copying the image, this is the highlighted code where we take that image and crop it from 00 to 224 by 224. Just take the top left side of the image of 224 by 224, and then save that image depending on whether it belongs to training, validation and testing. That way our data set becomes really small. So from if I use the entire image set, the data set was 9 GB, but with this approach the data set become 147 MB, which is pretty awesome because it was helping me to run the model faster. This is just printing those. So quickly we will move on to the various models. So basic CNN model I wrote from the scratch, which has 44 million trainable parameters, and it has different convolutional. So if you see this diagram, it has like two convolutional layer with with max pooling layer, and then one we using dropout uh, for not to do overfitting. So let me explain this particular model and their accuracy, show you in the code how it looks, and as expected it did not get the bigger accuracy because it's not deep enough to get those hidden feature which will be needing for solving this problem. So quickly, this is the model which uses various convolutional layer, 32 filters with 3 by 3 filters. Then it has a ReLU activation, and it has a dropout to not overload, and it has like pretty big CNN model but not deep enough. We get that, we print, and as you notice the image size which I use is 224 by 224 and 3 dimensions. After that we compile that, we have the loss function, categorical cross entropy. We are using Adam optimizer with 0.001 learning rate, and we are taking the accuracy matrix. So we these are the image data generator which I talk about, and these are pointing to the directories where we wrote those smaller data set. And as you see, it has it's getting 37 classes because we have 37 artists, different artists for those images. We train the model. I will not be able to show you this model because it takes long on my local machine. So I already ran it on AWS, and we will just see the final accuracy and final loss of those. So if you see with 30 epochs with 100 steps, I'm getting like 23% of training accuracy and 18% or 19% of validation accuracy, which was not good and which was expected. Like I expected that we will not be getting accuracy with this, because I knew we need to use the deeper network. And this is the test accuracy, just calling the predictor generator, get the predictions, and then use the confusion matrix from sklearn and accuracy score from sklearn to find out, and this is a 16% test accuracy. So now we'll move on to the next model, which is ResNet 50. And if you see the ResNet 50 is not only the deeper model, but it also uses something called residual learning. And so what happens, people are getting much better result if they go with the deeper CNN. And if you go deeper, that doesn't solve the problems like this very efficiently. It even starts degrading the results when the accuracy starts saturating, and it takes long time if you have deeper network. So to avoid this, the ResNet 50 uses the residual learning. This try to solve both the problems. And residual learning is nothing but, instead of learning the previous layer's input, it learns the residuals between the features. And what are residuals? You can simply understood as subtraction of features learned from input layer. And ResNet does this using shortcut connection, so directly connecting the input nth layer to the sum of the n plus x layer. And that is how it actually, and this is the PDF which mentions detailed residual learning concept. And here is the residual learning block. So if you see, the x identity is coming from the previous layer and shortcutting to the next layer by skipping few of them layer. And in the right side you will see this architecture with the right one diagram is the 34th layer residual model. So quickly I will show you the accuracy. So if you see, the depth is 168 and training accuracy is drastically increased, even the validation accuracy. So we are achieving almost 50% of accuracy using this model on the same image data set. So I will show you the code quickly. So this is how you download the ResNet from this application. I am using the previous weights, which is the ImageNet, assigning them the ImageNet. And this is, if you see, this is very long or the deep network, have multiple layers. I am retraining the last convolutional layer, because to solve our problem, it's better we train the last convolutional layer and use our dense layer the last, so it will classify with the softmax activation. And then we'll just created the generator, the same as explained above, and then passing it to and run the model. And if you see, the model give the pretty good 54% of training accuracy and 48% of validation accuracy. And we are just printing it in the plot, right? And the same way we calculate test accuracy, which is almost 45%. Quickly I will go to the third and the last model in my case study, which is a Inception ResNet version 2, which has a very deep architecture. And if you see, this is a compressed view of the architecture, which has a different layers. And if you see, the depth of this is 572, which is like 4 times of ResNet 50. And to prove the point that the deeper network doesn't necessarily works all the time, and that's why I wanted to prove. And if you see here, the accuracy is 36%, which we are getting almost 50%. So accuracy dropped. It took longer time to run. It has more parameters, almost double the parameter trainable parameter size than the ResNet 50. So let's quickly see that code. It's almost the similar code. You just use the different package module, get the Inception 50 Inception ResNet version 2 and train the model. And if you see here, this is the result set of that model. And let me just show you this. So we are not getting the nice accuracy as we were expecting. It is just 35%, even though we are getting the training accuracy better, but the validation accuracy is just 35%. So, and if you see the test accuracy, which is just the 34% as well. So to conclude it, ResNet works very well for this case study. And the point is only deeper networks are not always better. In fact, it could degrade the performance after training accuracy saturation. So just to conclude, the pre-processing of image data is most important task. So instead of rescaling for this particular case study, we have to corp it, and that way we reduce the data size as well as the accuracy. And ResNet 50 perform very nicely for this case study. Uh, Thank you so much for your time and watching this video.